Guys, hey, we're going to spend 3, possibly 4 days on just 9.1. Okay? This is the beginning of it. Okay? And again, we're going to show you guys some pretty cool tricks. Quadratic functions are linear, nonlinear.
Linear.
One or the other, they're not both.
Linear.
Think about it. Quadratic,
Non-linear.
definitely nonlinear.
Half circular. Oh.
I don't think they're circular because it can be written in the form f of x equals ax squared plus x plus c. What's the same thing as f of x that you already know?
Y.
Exactly. Fx and y are one and the same. So most of the time you're going to see y equals x squared plus bx plus c, where a cannot be 0. That's important. What happens if a is 0?
The x squared.
It's not quadratic, and x squared goes away, and then it becomes linear because it's bx plus c. So, all right, this form is actually called standard form. There are 2 forms of the quadratic equation. The other form is called x form. You don't need to know that one yet. That's later. Standard form. All right, the shape of a quadratic is called a parabola. Do not call it a parabola. That sounds like a bad disease. Okay, a parabola. All right. Now, everybody, pretend that you could fold the parabola directly in half. Would the right half match up with the left half if you fold it in half?
Yes.
Right? It has to do that. What's that property called when something like that happens? Symmetry. There are 2 m's in symmetry. Okay. All right. The line or fold that divides that parabola into 2 matching halves is called, this is very important, this is what we're going to be looking for today, the line of symmetry. Dun, dun, dun. That's what we're looking for, that line of symmetry. Very easy to find.
Isn't that just like
okay? So, everybody pretend taking a parabola, folding it in half, the line that breaks into 2 equal parts is considered that line of symmetry. Okay? All right. The axis intersects a parabola at one point called the vertex. Besides the axis, the line of symmetry, some people call it the axis of symmetry. We're also looking for the vertex. The vertex is always on the line of symmetry. If you can understand that, you're paying attention right now. Let's say that again. The vertex is always on the line of symmetry.
Very nice.
Does that make sense? When we graph one, it'll make more sense. So the vertex is always on that line of symmetry. Okay. This point is always the highest or lowest point, one or the other. They call it the high. If it's the highest, it's a maximum. If it's the lowest, it's a minimum on the graph.
I like it.
That vertex. If it's an open up one, the traditional one. Oh, jeez.
Me too.
Sorry about that. The vertex. Do you guys agree if it opens up, that's the minimum, that's the lowest point on the graph?
No.
And then if it opens downward,
That's the highest.
it'd be the highest one, it's the maximum. Okay? That's what that next line's saying. You need to know the maximum and the minimum. All right.
Isn't the maximum and the minimum where the line of symmetry is, though?
Yeah. And it would always be on the line of symmetry because the vertex is always on the line of symmetry.
Right.
All right, here we go. Graphing. Y equals A. Now, we're going to do ones, guys. Circle this. Today, we're doing where B equals 0.
So,
Somebody make that connect. What does that mean? B 0.
There's no Y
There's no what?
Y or
BX.
There's no X. There's no X. Because B is 0. 0 times X is
What about the
gonna be 0.
AX?
wait,
All right.
what about the
What
A?
about
And-
the AX squared then?
Okay. Well, we're going to eventually have a C today. But right now we're going to do one with where C is 0.
So it's just
I thought we were
Okay.
doing B
So
zero.
Y equals X squared. That is called the parent function. That's the mama or the daddy of everything. The parent function, y equals x squared. Okay? Graphs of the equations y equals x squared, or 2x squared, or a half x squared on the same coordinate plane. We're going to do that. Use the tables to help graph the equations, and what do you notice? Okay, here's what's going to happen. It's going to take us forever to graph these things because we're going to make an XY table. After we do this and look at I'm going to show you guys the trick, so you won't have to do this. But It's important for you guys to figure out the trick. All right, let's do this. You choose some x's. We've chosen for you -2, -1, 0, 1, 2. We've chosen 5 of them. Everybody, square those numbers and use parentheses. Okay, to get the y value, and then we're going to graph them. With parentheses around it, what's -2 squared? 4. I guarantee you, people, the point -2, 4 is on the parent function y equals x squared. Okay, do that for -1, 0, 1, and 2. Real quick, go. You're done in about 10 seconds. What's 0 squared, people?
0.
Genius.
Goes to the origin.
Goes through the origin. Like when you say smart things on film, Gardner.
I like it when he says smart thing.
Uh-oh. Here it goes. Do that right? I wrote that wrong number wrong.
Yes.
It's supposed to be a -1.
Or touches now.
Correct.
Sorry about that, guys. If you copied that second point down, I wrote it wrong. -1, 1, then 1, 1. Now you're going to start seeing some symmetrical aspects of this stuff.
2, 4.
4, 2, 4. So, all right. Now look at the table. Look at your coordinates in table form, and look at something weird happens.
-2.
It switches.
-2, -1, 0, 1, 2, going down the x values of each coordinate. Just like our 4, 1, 0, 1, 4. There's a pattern going on there. Okay?
Oh, does it start again?
All right. Now, what I want you guys to do next is go to the next page. Go to the next page. Now, I don't know what would make more sense in your head. I know the way I would do it. Would you want to graph that first one first? Or do you want to do the other two and then graph all 3 of them at the same time?
Graph all 3 of them at the same time.
Why would you?
Here's your choices. We have to graph all these. Would you guys want to graph the first one first and then go to the second one and then the third one? Or
Yeah.
let's do it that way. That's the way my brain would think. So,
Yeah, we just do
go down to the graph. We're going to graph, what were those points? It was -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, that's just that last table. Okay, let's graph those points.
Hey, Mr. Pensini,
I'm listening, Blake.
how come the fourth one down, the sign isn't negative? If it's switching between negative and positive.
Great question. Because when you square any number, what kind of number are you going to get? Whether it's positive or negative.
Well, it depends if there's parentheses or not.
There's good point. There's parentheses when you
Okay,
square.
you're gonna get positive.
Shazam. Okay. All right. -1, 1.
Okay, Billy Mays.
0, 0, the origin. 1, 1, and 2, 4. Okay. How many people got their 5 points are like that?
Oh, I get it.
Do you see a parabola? Okay.
I know.
This takes practice. Do not draw a straight line from one to the next. Curve it. Do your best to curve it. We're actually, the vertex is at the origin. Okay, and then there's some symmetrical. The axis of symmetry is actually the y-axis.
Do we have to remove
Okay.
rules now for this?
Murph,
So you wouldn't draw a straight line? Is that
going up your points. Guys, extend it. It goes on. Don't stop at those 2 side points. Go up a little bit and put arrows on, because it does go on forever.
Does it have to go?
Does that have to go where?
No.
That makes
Does it have
sense?
to go to a certain point, or can it just go anywhere?
Yeah,
Can say what?
Does the arrow have to go to a certain point, or like?
Oh, it goes on forever.
I know, but like, you can't have it like, going downwards. But
No, it goes up.
I know,
goes up.
but like.
Because, like, think about it. If we made a 3, you can do this one because it was y equals x squared.
Like, out.
Y equals x squared, guys, was the parent function. What's y when x is 3? 9. So you can do 3. The next set of points would be at 9 and -9, which would be maybe not that high, but like right there.
But
So
does it?
you don't have.
arrows have to go to a certain point, like.
Oh, you have to.
If
You'll see. You gotta
accidentally
get
draw-
basically you gotta get 5 points. With the middle one, Johnny, being the
Origin.
vertex. Just a coincidence that the vertex is on the origin. Doesn't happen every time. Does that make sense, Gardner? That's a really good question. 5 points, guys. But guys, I'm gonna show you guys the trick in a minute, and you're gonna be done with these in about 10 seconds.
Very nice.
Okay. All right. Let's do the next one. Go back to on this page. Let's do the This one's not the parent function. Then we're gonna make a be 2. Okay? So, show some work here. 2 parentheses, negative 2 squared. You have to put parentheses around that value you put in. Because you were squaring x, you're going to square negative 2 with parentheses around it. And then, who can give me the y value for that? Try to do that in your head. 8. Agreed. The point negative 2, 8. Okay, let's do the other ones. Y equals 2 times negative 1 squared. Notice, okay, that's 1 times 2 is, does that make 2, guys?
Are you multiplying? Yes.
What's your question, Bob? Yeah,
No,
order
I
back.
got it.
Your order of operations, you have to do exponents first. I should have mentioned that at the beginning. PEMDAS, exponents come before multiplication. Do not multiply that 2 times negative 1 and square that number. It doesn't work that way. 0, again, is easy. I shouldn't say that. What is that value, guys? 0. It goes through the origin again. Because 0 squared is 0 times 2 is still 0. Now here comes that symmetrical aspect. 2.
So we can assume the next one is 8.
8. Okay? These patterns can go on like this, guys, with these parabolas, because we're squaring x. Now, graph those points and watch for that. First, is this going to be skinnier or fatter than the first one?
Skinnier or fatter?
Way skinnier. You would think, I always thought, oh, we're putting a 2 in front of it, it's going to get fatter. We're putting a number.
Can you just graph it on the same graph?
Graph it on the same graph. And that's why I was able to do it in different colors.
It's a pure
So,
graph.
you know the origin, 0. At 1, it was 2. At 2, it was 8. So I'm going to go 1 unit off the graph. No big deal. At negative 1, it was 2. And at negative 2, it was 8. And I'm going to make my...
That is theoretically skinny graph.
Believe it or not, guys, it was skinnier. There's the second one.
Is it 8 at the top? How is it?
Oh, 8 would be at the top. Yeah, I went one off.
Wait, where?
1, 2, 3, 4, 5, 6, 7, 8 would be at the top.
I got it.
I did 9. I wasn't thinking. 8. Thank you, Miss Gia. Okay. So we put a coefficient of 2 in front of the x squared. If a is 2, it gets skinnier. What if we put a half in front of the x squared? What do you think is going to happen, people?
Divide by 2.
Do you think it's going to get skinnier, even more skinnier, or do you think it's going to get fatter?
Fatter.
It's going to get wider than the parent function. Okay, let's do this one. This one's a little tricky because they got a half, but deal with it. What's half of 4? 2. Negative 2. 2 is on the graph. Now, this one's going to work out to be a fraction, but we can do this. Negative 1 squared is positive 1. What's half of 1?
0.5.
Yeah, okay, what about fraction form? A half. So we actually got a y value of a half here, people. Or if you put 0.5, that would be fine. Negative, it's positive. Okay, how about 0? Do these always go through the origin?
Yeah.
When there's
Well,
No, they don't.
When there's an A, a B, and a
when A
C.
equals, or no, B
When x equals
Yeah.
0, you get
So
zero.
when X is 0.
When guys, it's all about C.
When
When C equals 0.
Oh, it says
I said
Okay, well, there's
So-
no C there basically because C
Well-
equals 0.
C equals 0.
right now.
Okay,
Because C is
just
not
for these.
there.
We're going to get into tougher ones, but again, I'm going to show you guys the pattern here in a minute. 1 squared, that's going to give us a half again. So 1, comma 1 half. And then at positive 2, 4, no, a half. So what's half of 4? Is it 2 again?
It's just positive 2 too.
Positive 2. Okay. So, graph the green one. Negative 2, 2. Negative 1, a half. The origin, 1, a half, and 2, 2. Okay? It's wider or fatter, the parabola.
Yeah, it is.
Okay? So the basically, the bigger the value of A, the skinnier the whole thing gets. Okay? If for some reason we put an 8 in front of x squared, it would be really, really, really skinny. Okay? All right, now. All right, switch to the next page. Go ahead.
So is y
I haven't told you the trick yet, but I'm going to. Be patient.
so is y the parabola curve just because it's not linear?
Right. Yeah. Big graphs of curve.
These graphs are so hard to see.
All right. What do you think happens if A is negative? You guys already know this.
It's gonna be.
Oh, it's a down.
Goes down. It's just an upside down cube. Okay. Because this is what's tricky. We got to get through this. Here's the work for this. Y equals negative parentheses after your negative sign -2 squared. Because you are taking the opposite of x squared, so I'm going to square my -2 because that's what x is, and then I'm going to take the opposite of it. This is a tricky concept for kids. Okay? When there's a number in front of it, you guys will totally get it. But because there's there's really a -1 there, but when you don't see a number, it gets tricky.
Wait, so it's -4, right?
I think it's -4. -4, -1 squared. That'll be -1, -1, -1. 0's not positive nor negative. It's going to be 0. This one goes through the origin. This is
calculators graph it for you.
yeah.
You just have to put in the point, right?
No, you just have to type in the equation. Give you Gardner. It doesn't give you the points. You know what I'm saying? All you do is see a U on your little screen. You know what I'm saying?
Wait, can't you just figure it out though?
I think you can just put you can scroll around with your little arrow keys, and you'll see a little dot go on the parabola, and it'll tell you the value of that dot. So you just keep scrolling around until you see points you are familiar with. All right, -1 quantity squared, or excuse me, +1 quantity squared. The opposite of that is -1, 1, -1. Look at the work we're doing here, people. -4. Does everybody understand why they're negative here? Yes or no? It's tricky. You were not squaring that negative. When we do the other one, the next one, you guys will be like, okay, I get it a lot better. All right, let's graph this first one. Is there a graph for you guys on the next page?
Yeah.
It kind of stinks. We got to go between pages, but that's okay. Okay, 0, 0.
Are we doing the whole packet today?
These notes, yes.
Oh, yes. Oh, that's what you're gonna tell us at the end.
Oh, that's very kind of you, Mr. Pansini.
I was gonna say,
no,
so I was wondering how you could do the homework about graph paper, and you said we don't need it.
Well, I just thought we were going to do like just I'm tired.
Okay? Notice it's the upside down of the parent function.
Oh.
It's the exact same thing as
It's the upside down of the parent function. Okay? So, what's one thing we've learned today, guys, about what A tells us?
If it's positive or negative.
Are we gonna make
Upside down or right side up. Also, it tells you about the width. It tells you if you get a wide one or a skinny one.
Mr. Pansini? Are we gonna make sideways parabolas?
$10,000 question. Don't bother me.
Is it?
No, there's no homework. But you're probably going to catch the rest of these notes.
Okay.
You want to watch them. Or just get them from somebody. So, go back a page, please. And let's do the ones where there's a negative A, but A is not 1. All right. Now this should make sense about your order of operations. Y equals -2 times the quantity of -2 squared. Everybody write that down. Try to do that in your head. How much is that? -8. It's 4 times -2, which is -8. -2, -8.
-2, -2, and a 2. But
Squared. It's, how much is that? -2?
-4.
I think it's -2.
Yeah.
Because -1 squared is +1, times negative 2 is negative 2. Again, I'm going to show you guys the trick in a little bit here.
Inch is right.
No, I want you guys to figure it out on your own.
Can you just do the first three?
And then know it's symmetrical?
Yeah.
Only if, great question, only if the third one is your vertex, which not always is.
It seems pretty
When,
typical
hey,
though.
when C is 0 and you set it up this way, the third one will always be your,
Okay.
So
If we do it
Mr. Pancini,
hold on.
if C is not in the equation, then we automatically know that C equals 0.
Yes,
So basically, since there's no C in all of these, C equals 0 for us.
correct.
Okay. Will C be actually a variable, or will it just be like plus or minus something?
Great question, guys. Will C be a variable or a number?
No,
What will
That's
C
not
be?
a no
a
answer.
number.
A number.
Okay, cool.
A number. 4, so that's negative 8. All right, let's graph this one. It's gonna be skinny or is it gonna be wide?
Skinny.
Skinny one.
Ooh, that's
Okay, the green one was negative 2, negative 8, negative 1, negative 2. The origin, 1, negative 2, and 2, negative. I just wrote them down so I can graph them.
Is there a way we
The
get
origin at negative 1, negative 2, at negative 2 is negative 8. Yes, this is a skinny one, guys. Seriously, if they put a big number as A, which is, you know, like if they put 15 for A, it's going to be so skinny. Okay? All right, do that last one with a fraction of a half.
Mr. Pansy?
Keep trying to look for this pattern. I'm trying to catch you guys caught on it. Go ahead, Blake. What's your question, bud?
For the parabolas, is there a way that we're gonna get like our x's to be like negative 4, negative 3, negative 2, negative 1, and 0, so that we only get half the parabola?
Yeah, but you want the whole thing, so you kind of want to look for the symmetrical aspect of it.
Okay.
Sometimes. Guys, eventually it is going to move left and right, the parabola. It's not always going to be right on the y-axis, symmetrical around the y-axis.
I don't mean to bug you, but you never answered my question about the sideways parabola.
I've already answered it
You did?
earlier in the year. Guys, when does it go sideways?
Never.
when it's
When it does. Guys, Blake's got a great question.
That's pretty sure.
When C equals
Y
two
is-
numbers.
No.
When A equals
Wait, when the x and the y actually switch, and it's
X
x
equals.
Oh, I
equals
get it.
y squared.
Ah.
You're not going to do that in this chapter.
It's horizontal because it's an x.
What if it equals negative y squared?
Oh, it's an x equals line.
What do you think? What happens
I
when
just
What a
said
great question.
it turns the other way, Sarah? Think.
I know.
Right. If guys, if y is negative, y squared is negative, it would turn the other way. All right, but we're not gonna do those yet. Let's do this stuff. So it's 4. What's half of 4?
2.
2.
Negative
Negative 2. 2.
Isn't it negative 2, negative 2?
No, I don't. Oh, is it negative 2?
Yeah, it's negative
Negative 2. My bad. Negative a
It's that
half
two.
times negative 1 squared, so that would be negative a half. So at negative 1, at y, x is negative 1, y is negative a half. At 0, it's still going to be 0, the origin. 0, 0. And then we get the symmetrical aspect going on here. 1, it'll be negative a half again. 1, negative a half. And then at 2, 4, we get 2. Destroy that number. Let's graph it. 2, 2. Again, this is going to be a wider parabola. A wider parabola. Okay.
I just wrote them out.
Negative 2.
That one. I think I did them all there. All right, so negative 2, negative 2, negative 1 1/2, the origin, 1 1/2, or negative a half, and 2, negative 2. So, it's going to be wider. Okay, guys, I know that's a lot of work. You will not do all that work. We're going to catch on to the pattern here in a minute. All right, let's see what we got. All right, we're on page. Okay, here's the stuff. if A is greater than 0. Okay? The parabola opens upward. A is greater than 0 just means A is positive. Think about it. What's A greater than 0? It opens up, and the vertex is a minimum. Okay? That's the minimum value. The vertex would be a minimum when it opens upward. What happens if A is less than 0? It opens downward. And the vertex is actually a maximum. Okay? What does the smart kid have a question now about? What happens if? Because there's one number that's not included there.
0.
Yeah, what happens if A is 0?
Then it wouldn't be.
It's
Turn back to the first page, guys. A cannot be 0.
otherwise it's not.
It's not a parabola, it'd be a linear.
Quadratic function.
Okay? All right. Graphs below. See if you guys can do this. There's 4 equations with 4 pictures from a graphing calculator. Match up the 4 equations with each parabola without any work. Brendan, sit! Quit bothering Amanda.
I didn't say
Yeah,
anything.
don't bother her.
Yeah.
Hey, with what you guys know, you guys can already start matching equations with parabolas.
Look what this says.
Okay. Are they already matched up together?
Yeah.
Yeah. All right, I thought this was a matching one.
Maximum.
Hey, those two go together. It's downward and it's skinny because there's a coefficient of -4. Okay. When you get a fraction,
It's
is
wide.
is 1/4 bigger or smaller than a half?
Smaller.
So it's even going to get when the coefficient of x squared when the a is a fourth, it's going to get really wide really fast. And then this is called the parent function. Everybody say parent function.
Parent function.
You know what y equals x squared graphs? Then you're going to be able to do a lot of this stuff.
And if it's x equals y squared, it's sideways.
We're not going to do those for a while yet, Bob.
Alright.
But you are correct. All right, now here's the trick. Now we wrote tables. Look and see if you can come up with a pattern of how you could graph these lovely graphs without a table. Okay? There's a ratio. Right? What I want you guys to do is flip back to like the second page on the parent function. Let me jump back there. Which would be, go back to the second page, guys, that we graphed those very first ones. Which color was the parent function there?
Blue.
Blue. Everybody focus on the blue or on your graph if you have a graph. Here's the trick. From the vertex, how many units did it go up to get from the vertex to the very first point?
1.
How many units did it go up from the first point that we graphed, not the vertex, but the point, and the next point?
3.
Now, what do we say that y would be when x is 3? You guys remember that?
Why would it be when x is 3?
What would y be when x is 3?
9.
9. Would that be the same for -3?
Yeah.
Yes. So 3, let's see, that was 8, 9 would be right here. So we didn't graph that point, but how much does it go up from the...
6.
No, count more carefully.
5.
5.
1, 3, 5. It goes up by 2 every time.
1, 3, 5. That's the pattern. All right? Go back to the page we were just previously on with all the in conclusion part. It is called the 1:3:5 ratio. And to graph these people, that's all you need to know is the 1:3:5 ratio. All right? If a equals 0, or if a does not equal 1, you must multiply your ratio by a and find your points in the graph using that ratio. And I'm going to show you guys how we organize our work and do this. Okay. Jump back to, again, page 2, the parent function. So we graph the parent ones. Okay, remember the skinny one, the red one? Okay. Was that y equals 2x squared? The red one? Okay. What was, watch this, 1, 3, 5. You're going to always write that down, by the way, on the side of your paper. What was the difference? I'm doing it on the other side just because there's a lot of mess on the right side. How many units does it go up? From 2. How about the next point?
2, 4, 6.
No,
2, 4, 8.
no. You're just saying numbers randomly. How many units does it go up? From here.
6.
1, 2, 3, 4, 5, 6.
2, 6,
Wait.
10.
Guess what? You got the right number.
Oh,
Hey, if we put 3 in.
You double it. I get it.
And then the next one's gonna be 1, 2.
Right.
The green
Because
one-
at 3, think about it, 3 squared is
The green one is 1.
9.
times
1.5,
2,
1.5, and 2.5.
18. So, we go all the way up to 18, pretend that we're 18. What's the difference between 8 to 18?
10.
What do you do with your 135 when there's a coefficient in front of your x squared?
Multiply it by the.
Multiply it by a.
And then for the green one, it's half, 1.5, and 2.5.
The 135, guys, always works. And I'll show you how to do it in a minute. We're not going to do well if, have to make all these tables that we've made here. All right, back to the in conclusion part. I think we're done with this. You're going to have to study these notes. Okay? The 1-3-5 ratio is huge. Next page. We're doing great. This is the most notes we've ever done in our lives. The most notes we'll ever do in one day.
You only have 3 minutes.
Okay, but we have no homework tonight.
Yay!
All right. Now, here's the deal. And yeah, we weren't planning on getting everything done today. That's why we aren't giving you. We're going to finish these notes tomorrow, and then you guys have homework tomorrow. It's going to be easy.
You get 7 problems.
All right. Let's see. Y equals x squared. All right. We've already done that one. Guys, remember what y equals x squared? That would be 4, 1, 0, 1, 4. Throw those numbers. That's the parent function. We're just doing it again, just so you can see how it moves now.
Red points.
Negative 2, 4. Negative 1, 1. The origin. 1, 1. And 2, 4.
Do you have to write the parentheses?
You do, yeah.
Okay.
Your high school teacher guys will not be happy with you. We don't put parentheses around your order of papers. Okay. But now, what happens if there's a C?
Then you subtract 2 from it.
Okay. Here, these ones are going to have. This is the parent function, which we're going to graph it. Well, let's graph that one real quick. Go to the very last page. I think that's where the graph is. Okay. Graph the parent function again. Those were
4, 2.
negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4.
If you have a C, then it won't be on the origin.
Eee, zip it. Very good, though, Amanda.
Oh, we've already talked about that.
Nope.
It's not Amanda.
talking. That was
Hi, Amanda. Valerie. Sorry about that.
That was
actually Laura, and I don't.
Yeah, totally.
Was it Val?
Yeah, it was me.
I thought it was you.
That was Brendan.
I don't sound any.
Okay.
I'm confused
Oh, you guys
now.
don't sound. All right,
I thought it was Brendan.
over there. Now, what happens when there's a C? A C of negative 2. Watch what happens. You got to show your work. Do you know how it moves out?
It is the Y.
Y equals negative 2 squared minus 2.
4.
0, comma, so 1.
Negative 4.
And then it just has.
No, how much is that, guys?
Negative
2.
2. Thank you.
Wait, there's no
4 minus 2.
Is there automatically always C's?
Whenever you substitute a number in and you're squaring x, you have to put parentheses right. Negative 1 squared minus 2. Negative 1
Oh, you subtract
by 2, right?
by C.
That's why there's
It's on-
minus 2.
It's on 0,
No, no, I'm
negative
talking
2.
about-
From the parent function.
Where's that?
Oh, that's pretty sharp.
Isn't that cute?
That's good.
I'm the good baseball mom. I'm the good baseball mom.
Johnny's at number 6.
Yes, he is.
Yeah, he is.
Don't do that to me.
Oh, yeah, we're like right in the middle. Very important. thing.
Very important thing. We got a
Good
minute.
baseball.
You know, I was thinking I would give him Really like a minute. sucker with it and be like, you're a sucker. No, I'm just kidding.
Very nice.
That's very funny.
To agree with that, he would be a sucker.
Okay.
I love how
Negative 1,
your wife's
negative
doing,
1.
like, right in the
All right,
middle of
guys.
them.
Hey, everybody, right now, somebody put a line, like put a star or something right where we are at. The second one on this one. We will finish this up tomorrow. Okay? I'm proud of you guys for all getting through the placement test. Okay? I'll see your grades in the next, your scores in the next couple days. But I think,
Can you tell us if we passed or not?
not until you get the letter.
Can you,
Why?
Can
You're
you-
never gonna know.
Mr. Pantine,
You
can
don't
you
just say
tell,
accelerator or not. You can just say like.
I lost our-
No, I don't say anything.
please tell us our
You
scores
said-
after we get the
Say
letter.
P. Well, they're killing you.
I don't, they saw those on scores.
Yeah.
I got this, I got that, and parents get
Yeah,
involved.
You said P or F.
Oh.
It shifts my job.
What if we all pass and then we killed him the next day?
But it
That'd be awesome.
Yeah.